Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have a conversation with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. A little bit of housekeeping up front here. I recently attended a small but mighty reality capture themed conference called Confluence. So the guest I have on this episode is a fantastic fit, even if I didn't mean for that to necessarily line up so perfectly. Universal alignments aside, I have been blown away by the advancements in these tools and in this space of reality capture. As you might have heard in the previous episode with Brian Ringley of Boston Dynamics and the Spot robot dog for autonomous job site capture, there is a lot going on. Terrestrial-based scanning, drones, handheld mobile scanners, laser scanning of moving objects like people, scanning levels of detail down to fingerprints, LiDAR on cell phones, you name it. It's not only an overly hyped technology on one end of the spectrum, but also an indispensable one in the modern toolbox. Try this out for fun. On your phone, go to Google and search for Neil Armstrong. In the results, you'll see his spacesuit in 3D, and there is a View in 3D button. The Smithsonian is creating these, and they and Google are hosting the scans on their websites, and the level of detail is incredible. And think about it, bringing these artifacts into the reach of millions of people that cannot visit the Smithsonian Museum is absolutely incredible, especially when you think of the limited number of items they have that are actually on display out of their entire catalog. It is immense, and they are bringing it to the world for free. Think of what we could do in the architectural and building industry. We truly live in incredible times. This episode is a conversation with Kelly Cone. Kelly is the Vice President of Industry Strategy at ClearEdge3d, where he brings together his experience in having worked in many facets of the building industry with his passion for implementing better ways to create the built environment using technology. And in this episode, we cover his path from architecture school to ClearEdge3d. We start with his education and his early days in an architectural firm where he shifted to implementing technology and BIM at the Beck Group, his stepping over the line to the dark side of technology from architecture, which are his tongue-in-cheek words, reality capture and laser scanning and all the developments that have happened in the space, both hardware-wise and in software. What does accurate or perfect mean in the reality capture sphere as it pertains to using the right tool for the job? What upcoming advancements in reality capture that Kelly is really excited about, and more. And if you've ever met or have seen Kelly in person, you know that he's a genuinely optimistic individual and is truly enjoying every part of what he's doing. His demeanor is contagious, and this conversation was an enjoyable one. So without further ado, I bring you Kelly Cone. Kelly, welcome. It's great to have you here.
Great to be here.
I wanted to start off, I think the last time we saw each other was in the session that you offered at Built, and I think that was Seattle in this case. That was a talk about people who have moved to the quote-unquote dark side of, yeah, it's a very controversial, clickbaity session topic. It was a great conversation. It was a panel. We had several people who've been on this show as well who are in that. So Anthony, you mentioned Anthony Hawk is on that panel. He came in late and dominated. We had Clifton, who is not shy from being behind a microphone. We had Purvi Irwin. We had John Pearson. There may have been others. But anyway, I mean, you basically created this topic because you have done a similar thing yourself. And I would love to hear how you got to where you are. So could you take us back down through the memory machine and basically connect the dots on how you got to ClearEdge3d?
Yeah, happily, and I will try and make it at least a marginally interesting story. So not a perfect version of reality, but a more interesting one. Yeah, I got my bachelor's and master's in architecture at University of Texas, Austin. So, hook 'em horns. Had a really unique experience there. I don't know if anybody's seen or done the solar decathlon stuff, but that was actually a really formative experience for me, because I'd always kind of played around construction sites and I'd built stuff, but I'd never built like a real building before. Just really, really enjoyed that process of taking what we had designed and making it physically real. And so when I graduated, I knew I wanted to go work at a design build firm. And so I, went up to Dallas. I was gonna have to go to Dallas. That's where the jobs were for people graduating. Interviewed at a bunch of firms, only one of which was design build. They were the lowest paying offer, but I believed in it so much. I took a couple grand less.
This sounds just like the story of so many architects, right?
Yeah. So started the Bet Group, which was a fantastic experience, fantastic company, and started out on the design side. Did that for about, I want to say like 9 or 10 months, and that was it. And then I ended up on the first Revit project of all things that the company had done. It was an unmitigated disaster. Terrible. I think we were like 4x over budget. And the truth was, it had nothing to do with using Revit and everything to do with the fact that we like cycled 13 people through a, 100,000 square foot movie theater, right? And most of them were people that hadn't worked on the movie theater side of the business before.
Or in Revit.
And nobody was on the project for more than 4 weeks. So everybody had to learn from scratch. So it was, the worst possible way to do a pilot project.
At what point did they say, just export to AutoCAD? Because I think that happened on every first Revit project.
So we stayed the course, gotta give points. Like, we finished it out. And I was the idiot that didn't have the political savvy to realize that when pulled in front of the principal's meeting and asked what went wrong with this project, that I shouldn't say we mismanaged it.
Put a target on your back right there.
So I said, well, I don't think it had anything to do with technology. I mean, would any project be successful if you did X, Y, Z, and kind of walked through all the, 7 deadly sins of pilot projects. We committed all of them. And somehow I walked out of that meeting not being fired, but instead being asked to run the Revit implementation for the whole company, which I think speaks to the character of Beck as a company. I was able to say the untactful thing and not get punished for it. But yeah, so I walked out of that room having stepped over the line in the sand at the Alamo, or they drew the line behind me, actually, is really what happened. I was just the only one still standing on the other side. And all right, let's do this technology thing. So I did that for the other 9 years of my career at Beck, implementing Revit and then Navisworks and then Innovia and then, what was the Autodesk product? Well, Autodesk bought Assemble Systems. Autodesk bought them, that replaced Innovia, and then blah, 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 blah. And probably about 4 years into that, so about 5 years at Beck, we had done a couple projects where we hired out laser scanning. In those 3 or 4 projects we hired it out, we could have purchased a laser scanner and hired somebody to operate it. So when next year's budgeting came around, it was like, I think we can do this. It doesn't look that hard. So talked them into buying a laser scanner, and which at the time was like $130,000 piece of equipment. And by that time, I actually had a team of people, and we basically ran that scanner and did 30 or 40 jobs the next year. And that's where I came across ClearEdge. We were doing a lot of scan to BIM. We needed help doing scan to BIM because you never have enough people. The volume was always greater than we could supply. So I was a customer for many years. I got to know them really well. And when it became time to leave Beck, I was kind of reaching out to Autodesk and ClearEdge and a couple other companies that I was fans of and knew people at, and ClearEdge made me a job offer. So I jumped to the dark side and became a software developer, sort of. I mean, really, I'm just a project manager in slightly different sheep's wool.
I don't think that's what your job title is, though. So.
VP of industry strategy or the VP of product management or something. But whatever. Anybody can put a title on a card. But at the end of the day, it's funny. It's like there's so much in common with just project management. That's a bulk of what I do. This morning I was on daily stand-ups, keeping progress on how the various different software projects we're working on are going, and people tell me what they're blocked on and how can I unblock you and yada yada yada. It's all the same stuff. It's just rather than the physical world, they're hammering on code. They need licensing agreements to get worked out instead of needing to get their plans approved through the code department, right? So it's just it's always something. Right. But yeah, it's not that big of a change in terms of the activities. Like the tools to use to do it, totally different. That was a big learning curve. But the activities, like at the end of the day, it's managing people and trying to help them be as productive as possible.
So give us an idea of what you guys make at ClearEdge. It sounds like there's obviously a software component to it, but I imagine there's a lot of interfacing with various hardware. You guys, as far as I know, don't make hardware, and there's a lot of great options out there right now, and it's changing rapidly. It's going mobile fast. And so I think, I'd love to talk about both of those topics from your guys' standpoint and what you're contributing to the overall effort on reality capture side of things.
Yeah, absolutely. So we basically make 3 products. So we're kind of working behind the scenes on a 4th. So the 3 products that we make right now, our oldest product, which has actually been around for over 10 years now, which is crazy, is Edgewise. And so this is, it's a tool that does scan to BIM. And if I were to try and characterize what we do at ClearEdge at a high level, not down to each little piece of software, it would be we try and apply artificial intelligence / computer vision / artificial intelligence is such a buzzword and it gets overused and it's not really understood, and where do you draw the line and blah, blah, blah. But specifically, we apply computer vision technologies to try and automate tedious processes at the intersection of reality capture and the built environment. So that's really what we do.
Let's stop right there. Just pause for a second. Let's define reality capture. I think that would be great, because this is something I just got back from a conference, and it really opened my eyes to thinking more holistically about what reality capture could involve. It obviously with certain service providers, it's pretty specific, but I think bigger picture, it's worth having a conversation about to kind of open that topic up to everybody who's listening.
Oh, yeah, absolutely. And I think it's, unlike AI, which is probably too broadly applied, I think reality capture is frequently too narrowly applied, because I think it's become synonymous with laser scanning, which I think is a mistake. I think taking photographs on a job site is reality capture. I think collecting, monitoring information from equipment on a building, and plugging that into its digital twin, that's reality capture, right? So to me, at the end of the day, reality capture is any technology that allows us to digitize the built environment, right? Well, to digitize the real world, truthfully, but we care about the built environment. So I'm gonna artificially narrow it. But within that lane, anything that lets us digitize the real world. So whether it's visual information, whether it's performance information, whether it's auditory, I don't care what it is. That's all reality capture. The question is, where is that useful? And there's definitely some areas where it's more useful, and definitely some areas where it's highly speculative. But yeah, it's certainly not just laser scanning. And, I choose to say that we're focused on the intersection of reality capture and the built environment very intentionally, because, I don't think long term that we're going to limit ourselves from pursuing other opportunities. The reality is right now, we're focused on primarily laser scanning information and to some extent photographic information. But it's pretty much all, visual or spatial. And that fits well with computer vision because that's primarily a method of processing visual or spatial information. And so, that's certainly where it does. And I just had Brian Ringley on the show from Boston Dynamics in the last episode that just came out. And he floated this idea of
continuously as built model. So because of Spot being able to walk a site on a daily basis in a familiar path and kind of figure out its way around new obstacles every day, it has a good chance of actually doing that same path all the time. And then using various sensors plus LiDAR plus computer vision with cameras and being able to identify and capture work as it happens, you actually have the ability on the design side and the construction side, if you're a CM or whatever, to monitor progress daily and have that be the reality captured that you can use as the data to back up exactly where you are in the process and what needs to happen next and how that impacts the schedule based on factors, various factors of real world construction sites, right? Weather and people not showing up and labor shortages and et cetera, et cetera. So I think that all of that kind of, for me, was a perspective shift from, something a one and done. I think a lot of architects think like that, right? It was like when we did contracts, we used to just say, you get renderings at the end of DD, and that was it. And then clients, because it was a big deal to do that and to do it really well. Yeah. And so you maybe had a specialized team. But now with real-time rendering, for instance, designers are spitting out beautiful renderings on a daily basis. And who cares, right? And the clients love that and they want it. And, before they used to say, when do I get updated renderings? And we were like, never, because you didn't, unless you want to, here's an ad service, right? But now it's just part of the thing. And I think we kind of thought of that with laser scanning as well, where this is a thing you do at a point in time, but now it's gotten to the point where it's so mobile and not just on an expensive robot, but there's handheld LiDAR, there's photogrammetry, there's 360 cameras, there's all these different ways to capture sites and progress that it really can become something that happens all the time.
Absolutely.
And the cloud connection, right? That's a big piece of it as well, right? It's just connectivity, because there is so much data that it used to be a huge hurdle to get over just to get that data. And it still is for certain types of projects that, especially government ones. But now to send that information to whoever needs it and have it available all the time is a huge piece that was missing for so long.
Well, and it's, I've always been a big advocate for taking a step back and realizing that maybe what you're doing isn't so new.
Yeah. Just new to me.
All.
Yeah.
It just feels new, right? Because it's we've been doing reality capture on job sites for decades. They're called photos. Yep. We've been storing them in file folders, and it's been a pain in the butt to share them and to organize them and blah, blah, blah. But we've been doing reality capture, continuous reality capture on job sites for decades.
Sketches, solving design problems on the site, and documenting those. Yeah.
Exactly. The only difference is now that information is being captured with additional data that is valuable in additional ways. And, we're trying to find better ways to communicate and store and manage and search and access that data. But the fact that it's collected with a terrestrial laser scanner versus a camera versus a mobile laser scanner is irrelevant.
Yeah. And it's spatial. I think that's what's most interesting to me is this is we're going into these 3D experiences with this data that you never had before. Exactly. You would flip through a folder full of pictures before and try to find the one that you're looking for based on what? I don't know, just scrolling, making the icons as big as you can. And that was all we had. But now it is, because it is spatial and because of the way our brains work, it makes a lot more sense to just go inhabit that space virtually and find what you're looking for. It's pretty fantastic.
Absolutely. And it's fun to see because I feel like, we are at this interesting inflection point in the spatial reality capture timescale. Because, if you go back 20, 30 years and talk about some of the original, Cyrix scanners, right? These were things that had a very narrow field of view, much like a camera, right? They would, you would have to turn it and focus it on one area. You'd scan one area. It would take, 12 hours to scan it.
Right.
And you'd have this, little window, 30 by 30 or 60 by 60 of dense point cloud data of questionable accuracy, plus or minus a centimeter at, whatever range. But people just loved it because if you needed to document a bridge or a dam or something like that, it was a much better way to do it from a distance. So remote sensing. And then, what we've seen kind of the rise of terrestrial scanners, and that's kind of plateaued because if you think about kind of the top of the line instrument right now, it's really the RTC 360. And it has some compromises. It's not going to give you survey grade accuracy from its inclinometer, right? So you may need something else to help get that kind of accuracy on levelness. But other than that, it's a beast of a machine, right? 2 million points per second.
That's amazing.
All this crazy stuff, right? And it's kind of at the point now where the scanning is faster than the imaging. It takes longer to take the images on an RTC 360 than it does to do a high res scan.
That's insane, right? Because it is bracketing. It's trying to give you range in those photographs. So, but yeah, it takes longer than a scan.
Give you HDR, right. And it's got to take 37 photos and blah blah blah, and it just takes a while. The innovation in laser scanning for terrestrial laser scanners. I mean, yes, sure, they could come out with a 5 million point per second scanner. I'm sure it's possible, but why? Yeah. Nobody complains the RTC is too slow scanning, right? Yeah. So, we're kind of seeing terrestrial plateau, but terrestrial enabled kind of the capture everything once mindset. And so for a long time, the value proposition for scanning was rather than going out and taking, isolated measurements to come up with your floor plan, you just go out and scan, and then later on, you can do your scan to BIM and you get an as-built and it's accurate. And even if you didn't know that ceiling heights were important, the client changes their mind later and wants to reuse the grid. Okay, well, you already captured the grid because you captured everything.
Throughout the process. Yeah, before something was even covered up, right?
Yeah, that's the value of okay, gosh, we've captured everything that's there and we can do whatever we want with it after the fact. I think that type of scanning is, still going to grow, but it's slowing down. And I think if you think about the continuous kind of representation of reality in a digital environment, if you think about that continuous reality capture, so much of that data is redundant. So imagine going out to a job site with a spot and scanning every single day from the same locations. 98 to 99% of those points will be completely duplicative of the scan from the day before.
You just want the difference filter in Photoshop to say what changed.
Right. It's a waste of time to capture that information. It's certainly a waste of time waste of money to store that information. So I actually think we're reaching this point where we're going to start to see more scanners that are back to kind of a field of view. Back to only scan what you need to, only scan what's different, only scan what's changed because anything else is inefficient. And so it's fascinating to kind of see, I think it's going to eventually come back full circle because once you are out there every day with, under $10,000 equipment that's capable of high accuracy scanning or under $5,000 equipment that's capable of high accuracy scanning, you don't need it to scan 360, 270. You don't need it to scan everything. You just want to get what's new. So it's going to be a fun 10 or 20 years kind of watching this progression, watching mobile scanners kind of reach the level of accuracy where they can truly start to displace terrestrial scanners from their primary use case. Because while they're taking off, the reality is most of the mobile scanning use cases are new use cases. They're things that people never thought of doing before with a terrestrial scanner because it took too much time and money to do it with a terrestrial scanner. And now that you've got mobile scanners, it's cheap enough to do these additional things that have a lower accuracy requirement. And that's where mobile scanning is really growing right now, is in all of these additional use cases, real estate planning, et cetera. I would go down that road. But you're not seeing many people build highly accurate as-builts from mobile scan data, because it's just not quite there yet.
I want to get to the accuracy conversation, but I did interrupt you in the things that you guys are working on at ClearEdge, and I would love to get back to that, and so you can finish that thread, and then we can move into some of these other things.
Well, sure. I mean, give me a chance to talk about my technology children.
Yes.
Yeah. So going back to what we focus on doing is automating tedious tasks using computer vision, focused on that intersection between reality capture and the built environment. So Edgewise is our oldest child and
most mature.
Yes, sure. It's only 11 or 12, loaded, so let's not go down that word. But certainly the most troublesome. But Edgewise, basically, for very specific scopes of work, Edgewise will automate that process of getting the scan data and turning it into a building information model. For instance, piping, like if you've got piping networks, you can load in 20 or 30 or 100 scans in Edgewise, click a button, go get lunch if it's 20 or 30 scans, go to sleep if it's 100 scans, come back, and 80-ish%, depending on the quality of the scan data, maybe 60% if it's lower quality scan data, maybe 90% if it's really clean data, of the pipes will be automatically extracted.
Interesting.
By pushing one button.
That's incredible.
And then we've got some other cool tools to stitch them together into networks automatically, find elbows automatically, standardize them automatically, et cetera, et cetera. But we can basically, if you had a big plant and process job or a big central plant that you need to document, we can take something that might have been 3 weeks or 3 months worth of human time, and we can compress that into a couple hours or a couple days. Wow. And so that is a huge productivity benefit on the piping network. I didn't say we modeled pumps. I didn't say we modeled every flanged valve and got it down to the type of valve and this, that, and the other. Those are things that are really hard to train a computer to do. So again, we focus on that. How do we train a computer? What can we train a computer to do to automate a very tedious task? And we focus on that. So we do that with pipes. We do the same thing with structure. Sequence of automation is a little bit different. It relies on the patterning of structures, essentially. That's one of our many patents. And we basically have a super smart array tool where it uses an array as a seed, and then it refits every single element within that array to the point cloud and resizes it and rotates it, and blah, 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 right? We focus on things we can automate because you can't automate everything right now. And so we aren't a soup to nuts scan-to-bin modeling tool. We don't do that. We automate stuff. So we can take your man hours on a project and cut them in half or cut them to a quarter of what you would normally spend, depending on how much of that work is pipes, structure, walls, rectangular ducts, conduit, round duct. I know I'm forgetting something, cable tray. So, a lot of it's on the systems side, which, as you know, modeling systems in Revit, particularly trying to get them as built, really sucks. And then we do walls, and then we do structure. And so as we find new things to automate, as new techniques become available, we're super interested in what we could do with machine learning. It hasn't really delivered yet, but, that's something that obviously we'll be watching carefully and continuing to experiment with. But as new things become automatable, we will be delivering those additional tools. But that's really where we kind of see ourselves in the space. And so on the scan-to-BIM front, we've got Edgewise, and then we have some tools that focus more on quality control. So we've got a tool called Verity. Verity is basically an automated tool to compare a point cloud against a model. So unlike Edgewise, which works with specific things, Verity works with anything. We've had customer calls with people in Africa that are checking the quality of a statue being built by an artist to make sure that they're getting charged the right amount, for these huge bronze panels that are like warped and folded. We've had calls with people doing work on dams, calls with people doing work on just all sorts of crazy stuff.
This is a really interesting one. I saw it as something that kind of blew my mind, which was to kind of, again, rethink the idea of this scan once versus scanning all the time. They were, and I'm assuming this was actually a Verity application, which was scanning during a concrete pour and checking for flatness before curing so that they can see it exactly where the low spots and the high spots are before it sets, so that they can fix it then and not have to come back and come out and grind and fill or take it out and do it again. And it's a huge, huge deal.
Absolutely. And so that's actually our rhythm application, which is focused very narrowly on concrete as a trade work. So that's our third tech baby, which is really an adopted child for us. Shout out to Philip Lorenzo. Philip came up with rhythm ages ago because basically he kept seeing people using the dipstick out on the job site. And anybody that's ever worked with a dipstick, we've all probably worked with a dipstick. Oh, I'm not talking about the person. It's a piece of equipment for measuring floor flatness, but it's a super, super weird mechanism and technique for measuring flatness that's really abstract and really dumb, actually, when you think about it, given what we have today. But it's the standard that's accepted, so you have to do it. So he figured out how to reproduce that in code from scan data, and had been selling this as a plugin for Ferrocene for many years. And then basically they decided to get into something else, and they started licensing out that. So we picked up a license to do that. You'll also notice that some part of rhythm is included in like a suite. Some part of rhythm is included in some other stuff. So it's like Philip's tech baby has spread its wings and flown the coop. It's a really neat tool. We've kind of got the full soup to nuts suite plugged into Navisworks instead of Ferrocene. So you can use any scan data with it instead of having to use Ferroscan data or having to buy scene just to convert it to do this. So, but yeah, rhythm is focused on surface deformation, specifically on concrete trade. So beam deflection after you pour concrete, blah, 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 ADA slopes, all sorts of cool stuff. But yeah, and Verity generally gets used for construction verification because that's the obvious, after work gets installed, scan it and then test it and then give your subcontractor a report of all the stuff they did wrong, and they can either fix it or update their as-builts, right? But it's also like one of my favorite use cases for it is actually, I'll tell you one that'll scare you less first. Probably the second most common use case for it is to check the quality of scan to BIM deliverables from third-party service providers. So have scan, send to India, send to Indonesia, send to China, send to even somebody here in the States, have them generate a BIM, send you the BIM. How do you know that it actually meets the specification? Yeah. Run it through Verity. We'll give you an itemized report of everything that doesn't meet the specification.
Accountability machine right there.
So that's another great use case for it. But my favorite one, coming from a design build company, is after getting a design model that I'm going to be using for coordination and construction, going out and doing a scan of an as-built, so on any remodel job, and then running the design model through Verity against the scan. And it gives you an itemized list of everything in the design model that varies from the actual infield, construction conditions. And so it's like the easy as possible button for verifying fields, right? You just let it run, come back. Here's all the walls that are more than half an inch out. Here's all the this that's more than half an inch out. Oh, notice how the floor does this, right? So it's just a really, really great tool in that situation as a contractor to understand where those gotchas are going to be, and then be able to early and upfront get those documented as RFIs, get them resolved before they cause problems in the field, before they delay the project, before they, all this kind of stuff. So that's my favorite use case for it, actually.
Okay, so before you scare me now, this I wish I had this when I was remodeling my kitchen, because my house is from the 40s, and I feel like such an idiot, because it's like, the room looks square. And then you actually go to hang those upper cabinets and you go to put in that countertop, and wow, it's so off, right? And I think, this is just, again, like thinking about this coming from the architect side, just because you draw it this way doesn't mean it is built that way or stays that way over time. And, because things do move, they do settle, they do cure, they do all these things that are organic in nature. You can't assume that it's flat, level, and square. You just can't. And But we do it all the time. And that to me is the biggest benefit from a direct application to what we do, because we're doing a ton of remodel work. We're doing a ton of reuse and adaptive project types where you're taking some bones and you're putting a new skin on them. This is a huge deal.
Yeah, and it's not, and the thing I always like to remind architects is it's not that you as an architect need to learn how to design to an as-built condition per se. It's not like you need to take your design to effectively the level of shop drawing so that you can accommodate for all those as-built conditions. Right. It's that knowing about the as-built condition allows you to make intelligent decisions about what matters most.
Absolutely. I would never want that model to build off of. It's like I've had projects scanned before, and the scan to BIM, it was too accurate, and then it's useless because I can't even snap a dimension to it in Revit, right? Because the slightly off angle warning comes up all the time, and I can't deal with that. But you're right. It empowers you to know where to build your margins in so that you don't have to figure it out when it's really expensive to figure it out.
Yes. And when you oftentimes can't afford the good solution anymore, or it takes too long to get the good solution, and so you end up with a half-assed solution. Exactly. It gives you that information up front, and that's what it's there for. So when you're placing those uppers that this wall leans this way, the other wall leans this way, and your uppers are going to be 2 inches longer than your lowers. And how do you want to make that up? Do you want to make that up distributed across every one? Do you want to have a filler piece on the end? Do you want to, how do you want to handle that? Well, you don't have to draw that, but you can put a dimension string on it that specifies that, no, I want these equally spaced, or no, I want these right justified, or I want these left justified, because I know, and then leave that in dimension and put verify in field, right? But if you just put the whole thing verify in field, and it's like, all right, well, the guy making the cabinets is going to figure that out for you, and you may not like it.
That's true.
You may not like that 2-inch spacer he puts right in the middle of your uppers because he put the ones in the corner first.
That's a great point, because I think, construction used to be done with a lot less drawings, right? And it was left to the contractor's expertise to figure out a lot of the stuff in the field as they were building it and solve those problems the best way they knew how. And we didn't have to cover all of that minutia in the plan set. But another way to look at it is empowering now to have that level of control potentially on your project, depending on the project type, early on, so that it is obvious when it actually comes time to construct it that you have an expectation around those things rather than waiting to see what they come up with. So Pick your battles there.
Yeah, and just we can lament how sad it is that the trades are no longer capable of making good design decisions anymore because the quality of their labor force has decreased, and the people installing work are no longer master carpenters. They're guys with 6 weeks of experience, right. Out on a job site. We can lament that all day long, but that doesn't fix the problem. Right. It's still going to be a guy with 6 weeks experience hanging those cabinets. So, how do you make sure that that's done right? Okay, well, got to do a little more thinking up front, but we have the tools to give us that information. And so, not using them is basically, that's a pretty poor excuse for bad design. Or bad outcomes, maybe I should say, because it's not bad design, but it's just you have the power to avoid a bad outcome. Why not use it?
Well, let's talk about accuracy. There's obviously a lot that can be said to different types of capture. Photogrammetry is a lot different than a laser scan. And then you mentioned, the level of accuracy and application for handheld scanners versus, tripod-based kind of lockdown stuff. So one of the things that was interesting to me to think about, and all credit here goes to Nick Cameron over at Perkins and Will, because we were talking about Matterport one day, and Matterport is huge in the real estate. And then I do see architects, buying these things up because they're incredibly affordable and also valuable, especially when it comes to being able to have a client walk through, in air quotes, a building remotely. Especially during COVID, this is a very big deal, and it should be built into every architect's photography schedule and fee, right, to get this done, because it can be useful for a lot of things. But it's obviously it's infrared, so it's not like a laser scan. They say it's 99% accurate, but if you do the math over every 8 feet, that's about an inch, right? So that's quite a big number when you think about it. But the way Nick put it to me, and it made a lot of sense, was it's still better than an intern and a tape measure. 100%. Because I've done that. And I think once you hear that and you've done it, you know exactly what he's talking about. And so for many aspects, as far as, I wouldn't maybe go as far to call it a digital twin, because I think that, again, buzzwords and loaded, it's there's a lot there. But it is useful in a lot of ways. And so accuracy, in quotes aside, there's different applications and usefulness for different types of capture. And I think it just comes down to knowing what you want in the end before you decide. You can't just say, we're going to buy this Matterport and use it for reality capture. We're going to buy this BLK 360 and use it for, you got to know what you want out of it in the end. And a lot of times it's going to come down to having multiple tools in the toolbox to achieve the results you're looking for.
I mean, you don't send a guy out to a job site with a Phillips head screwdriver and expect him to pound nails. No, I mean, it's very true. And I think, manufacturers are very guilty of, or at least very complicit in kind of advocating this one scanner to rule them all.
Or accuracy is the only thing you want, right? Like really highly accurate, again, is always within some margin, but you can't just say that other tool is useless because it is less accurate.
Yeah, or that tool is useless because it's most accurate. I mean, I think each vendor, the ones that produce more accurate equipment like to poo-poo the ones that produce less accurate equipment, and the ones that produce faster equipment like to poo-poo the ones that produce slower equipment. It's the lovely marketing game.
Yeah, and service providers like to poo-poo whatever machines they don't have, right? So...
Yeah, exactly. It's like, oh, well, I don't have that. So I better come up with reasons why it's a terrible instrument to explain why I don't have it, right? So but at the end of the day, like, I think pretty much every scanner out there that sells any number of units sells them because they have a valid purpose, and that purpose is unique. So, like, I'll pick on my parent company a little bit. So, what you see behind me here is a lovely Topcon GLS 2000. Which, if you put it in a horse race against even a last generation terrestrial scanner from any other vendor, would finish dead last by a long shot. In a race for productivity, how many scans can you do in an hour? How many scans can you do in an 8-hour day? It'd be last, guarantee you. This is not the scanner you buy if you want to crank out 50 scans in a day or 150 scans in a day, right? But it's got some really unique characteristics that, of course, everybody else likes to, right? Data's super clean because it's still a time-of-flight scanner. Nobody makes those anymore because everybody uses phase-based because you can get such higher scan rates. But this is designed for horizontal construction where range matters more than speed because you don't do that many setups. And so it can shoot up to 1 kilometer. Its time-of-flight data is super nice and clean. Every time it shoots the laser, you get a point. You don't have to average across multiple points. It has some really unique scan patterns that are designed to get you better density on a flat surface relative to the scanner. So, like, there's really cool. And so as a result, it's really stinking great for floor flatness, because the difference in being able to turn around that result that you mentioned before, right? When you're talking like, oh gosh, in 10 minutes, I need to run a scan, run it through Rhythm and get my heat map or get my contour map. So I know where to go run the little whirligig machine.
That's it.
Right. Or the screed or whatever I'm going to use to move the concrete around, or where do I need to pour a little bit more concrete before the concrete truck leaves? Well, if you have to do 3 setups, you're done. And so, I can, from a single setup with this instrument, do 4 times the floor area that you can with anyone else's instrument, because it's time of flight. It has a high intensity mode, so it'll get reflection on wet concrete much further away from the scanner than any other scanner will. And it has a pattern that gives me a nice, even distribution of points on that surface, even very far from the scanner. So I can do it in one setup with this instrument, and you can't do it with a Farah. Can't do it with an RTC 360. You can only do it with this instrument. And so, like, there's things like that where even though it's slow, it needs to be put out for pasture in a horse race, useful. Right? Yet if it's floor flatness, this thing kicks everybody else's butt, right? And so, there's tools like this that are really great for certain niches. And then you've got great general purpose scanners. RTC 360 is fabulous, but the data doesn't come out very level because it uses an IMU. So it's a very low accuracy levelness. So don't do floor flatness with an RTC unless you have something else to augment that levelness, right? Same thing's true with a Faro. And there's ways to do that, but yeah, there's just lots of tools for the job. And if you want to go into accuracy, right? Terrestrial scanners are going to get you anything from sub-millimeter to plus or minus a couple millimeters, or all the way up to something like the BLK, which is going to be plus or minus probably about 5 millimeters, right? So, or plus or minus about 1/8 of an inch. So that means you'll have a 1/4 inch of noise on a reasonable surface. But all of those are measured, and this is what will drive you crazy. You have to look at the detailed specification, and you'll see that that's measured on a surface with a certain albedo, which basically is how bright the surface is to the light, and at a certain range. And then that accuracy will vary, of course, based off range, based off surface reflectance and albedo. So it's a matte, bright surface, and that's kind of the best possible situation. What they don't tell you is how does it perform on a matte, dark surface, or how does it perform on a shiny, smooth, reflective surface, right? So the specs really are extremely difficult for the average person to interpret and understand. So I always tell people, just never believe the specifications that any manufacturer sends you ever. The only way to validate whether a laser scanner is going to be good for you is to have them show up at your job site and run a couple scans, see how quickly it works, see how easy it is to get on control, see how easy it is to do the things you care about, and then make a decision. Decide based on your use case which scanner is going to be best for you, and based on the data that you get back. Demand the data back. Look at the data. Oh, has it got good data on a duct? No, it's got terrible data on a duct. Well, the ducts are what I care about. Probably not the best scanner for you. But you've really got to get the data in a real world environment, see it, and validate whether it's good enough for your use case. So I'm a huge fan of hiring out scans, having manufacturers come demo them on your job site. Really do your due diligence, because they're still expensive things. You don't want to go spend $50K or $150K. And that's just the instrument. That's, then you've got software, maintenance on that software year after year. You've got an operator, you've got all this other stuff. So, make a smart, informed decision on this stuff before you buy it, and get lots of demos, get the data, look at it, interpret it. Because the accuracy is, the accuracy of the scanner is one layer. You've also got the accuracy of registration.
Can you define what registration is real quick before you, because I think I know what you're talking about, but I want you to tell us.
Yeah. Matching scan 1 to scan 2, right? So scanners are all line of sight. So if I ran the scanner right here, it doesn't see what's behind my door over here because my door's open, right? If I then have to move my scanner into that hallway, so I get what's behind that door. Right, so you have to do multiple setups with any laser scanners. With a mobile scanner, you just walk, but you have to walk anywhere you want it to see, right? And all of them have to be registered. And so the thing to remember is laser scanners are just measurements, just like a tape measure. So the reason tape measures are so much less accurate is because, a person is not very good at, holding a tape measure perfectly taut and straight along a very long distance, and then recognizing that 1/16 of an inch variance, and then documenting that consistently, and then checking right angles everywhere and writing that down, and then doing the trigonometry to figure out real distances. That never happens. So you get approximations all over the place, but you also get chain error, measure to measure to measure. So if anybody's done this experiment, right, where you take a laser disto and you run it down a long hallway, shoot it. Now, take the same laser disto or a tape and measure each individual bay, or door to door to door to door to door to door to door, and you will come up with a different measurement, because every measurement has an inaccuracy, and those add up. They compound over time. And so scanners avoid that within a scan location, because every measurement is from the exact same point. So you really only have the error the instrument introduces into each measurement. And that's somewhat ameliorated by the fact that those measurements are beautifully statistically distributed, which is a fancy term for saying that it's plus or minus whatever the manufacturer says it is on that surface, But on average, those measurements will be much closer to the real world. So if you have 10 million measurements on a wall, you've got a pretty stinking accurate determination of where that wall is. Sub-millimeter, probably tenths of a millimeter, if you average all of those points, even though each individual measurement might be plus or minus 5 mils, right? But when you start chaining stations together, every one of those is a new set of measurements. And so all of those, that will compound error, just like with a tape measure. So registration is that kind of chaining of multiple stations together. And so that has a certain amount of error in it. How closely does scan 1 match scan 2, match scan 3, match scan 4, match scan 99? And so there's all sorts of techniques to manage that, whether it's making a lot of small loops and closing them so that you can kind of correct that error across 5 scans or 10 scans. There's also, on larger jobs, you'll want to do some kind of a survey control where instead of relying on every scanner overlapping with the other with cloud to cloud to go down a 200-foot hallway, you also have a total station that sets up at one end of the hallway and does that long single measurement to the other end of the hallway. And then the first scan is on a control point, the last scan is on a control point. You've constrained that chain. And you've basically been able to get it down to a single measurement's worth of error across that particular line of scans. So tools to do that, but that introduces error. So anybody that can tell you on a 1,000,000 square foot building that they're going to give you scans and that every point will be plus or minus 1/8 of an inch from the real world, you're spending a whole lot of money for a whole lot of super accurate survey control to deliver that. If you can loosen that up to plus or minus 1/4 of an inch, you get that job for a lot less money.
Plus, you got to manage all that data in the end too, which is not something to take lightly because there's so much.
But the accuracy is I think it's over worried about for the reason you mentioned before. Any of these things are infinitely better than an intern with a tape measure,
And beyond that, it's like the photography part of it is huge, right? Because you're getting these 360 photospheres for every station that you scan at, which then I can look around at later. Like, this is a big, big deal because I'm not constrained to where they pointed the camera when they were there that one time or the 4 times that I had to send them back. I'm getting all of that. And that right there is worth it as well. I mean, that's huge.
Yeah. So it's like, but this is so much like, this is always like the challenge with technology is I feel like whenever you adopt a new technology, everyone likes to compare that technology to perfection. Rather than comparing that technology to what you're currently doing to do that same thing, right? So it's like, even a Matterport versus an intern is a big win, right? And over a 1,000,000 square foot building, you could be feet off with a Matterport. But with an intern, you will be feet off. I guarantee you. You may be tens of feet off.
And you didn't get all the photos you needed either.
Yeah. So it's like, there's such a huge value add that it's like, stop comparing it to perfect. Like perfect doesn't matter. There is no perfect measurement regime. They don't exist. I mean, the building moves over the course of a day. Define perfect. What time of day is perfection achieved? Is it noon? Is it 8 a.m.? I don't know. I'm an evening person, so I'd say like 8 p.m. But that's one of these kind of funny things where it's like, you can't compare something new to perfection. Otherwise, you'll never implement it, and you'll always be using something old that's way the flip worse. So just like think about it contextually rather than, this Cartesian, is it the perfect measurement tool? No, it's not. But it's not. But it's
Magellan
great.
would
It's
be proud.
amazing.
So
But
when this, I'm just wondering, like, where do you see it going from here? Obviously, mobile is a new thing, right? We just saw, I think it's just came out, right? The BLK2 Fly, which is drone LiDAR, I think. And obviously the Matterport infrared stuff is great for interiors, but you can't use it outside during daylight. So you've got to do some kind of photogrammetry, or you've got to mesh a point cloud and apply
or terrestrial laser scanning or something.
So it seems like, maybe there's some more convergence of all this in the future. There's obviously ease of use, operator prices are coming down. The whole world is getting captured at various levels of detail over and over and over again. It seems to me like there's opportunities there to really standardize and make available these data sets. Yeah, I know that I can't even get you can't even get a 150 person firm to use the same Revit families, let alone standardize the world's data sets. So where do you see things going? What are you excited about in the reality capture world?
I mean, I think I mentioned earlier, I think we're rapidly approaching the point where mobile scanners are accurate enough to replace things we are using terrestrial scanners for. And that's exciting because the productivity of a mobile scanner is 10x or 50x what it is with a terrestrial scanner. Even with a top of the line, super fast terrestrial scanner, if I really wanted to cover every square inch of my little 2,000 square foot house, that's probably 75, 100 scans, and that will take me an entire day. Give me a Naviz VLX or a GeoSlam or any one of these handheld or backpack mobile scanners, I can get the same amount of coverage and a comparable amount of, what's the right word here, a sufficient amount of density. Like the terrestrial scan data will be more dense, but it'll be overly dense. Right. I mean, I'll have like a point every 1/10 of a millimeter in some parts of my house, right? With those, 75 or 100 scans. I'll get not that level of density, but more than good enough density in like a 10-minute walkthrough in my house. So going from an entire day to 10 minutes, it's pretty awesome. But right now that comes with a pretty big sacrifice on accuracy. So if I want to do any prefab, because I've got a remodel planned here, like I do at every house, if I want to do anything prefab, I'm not going to do that off mobile scan data because I can't trust it that accurately. Like I can't fabricate down to something with 1/4 of an inch tolerance and actually trust that it will install correctly when it gets here. So, those are, right now there's a trade-off, but we are maybe 1, maybe 2 generations of hardware away from mobile scan data being able to deliver that comparable or sufficient level of accuracy for those kind of use cases. You'll still have terrestrial laser scanners for super high accuracy stuff where you really need plus or minus a millimeter. You'll still need terrestrial laser scanners for long range accuracy. If you want to shoot up to 1 kilometer with a high degree of accuracy. So there'll still be a place for them, but I think they are on the downward trend. I think we will see them, if they're not already maxed out in terms of market share, they will at least plateau very soon and then start to fall off and be replaced by mobile scans. And I think that's a given. I'm super pumped about silicon-based LiDAR. So right now you get these, fiber lasers that are zapping a mirror that's spinning, and you've got all these mechanics and everything else that can break down and fail, and that's how LiDAR works. But all the cars that are self-driving, minus Teslas, that use LiDAR chips, they're actually using silicon-based, they've got a little circuit board that's generating light emitting, it's emitting light and it's hitting something on silicon that's, a little MEMS chip that's redirecting the light so that they can do all of its scanning. But it's not a big rotating mirror that's like steering the laser. So we're right now we're basically at the point where we have much smaller form factors for cars where the steering of the laser is being done on silicon. The light emitting is being done separately. And you've got, still a factor that's, like this, right? It's like a big chunky thing you can hold in your hand, but it's a lot smaller than that. But they're geared for long range and relatively low accuracy because you don't need to know if that car is 200 feet away plus or minus a millimeter. It's good enough if it's plus or minus a foot. So I think that'll change over the next 5 to 10 years, and we'll start to see that and advances in that space, getting it all truly on a single chip, actually filter into our space with higher accuracy uses on the robotics side. So I will go on record. I love Brian. I love Boston Dynamics. It's super cool. But I think it's a big, fat, honking gimmick right now. It is the biggest BS gimmick you can imagine. It does not work on any real live job site. And everybody that I've talked to that's tried to apply it will tell you that. And it's not because it's not cool and needed. It's just actually putting that in production. There's just too many barriers to it in real world applications right now.
Well, and just looking back to where laser scanning has come from, you see this process that everything has to go through to get to the point at which it is applicable and useful.
You have to go through the gimmick phase. So Totally. It's not a dig. I'm not digging them. Like, you got to get through the gimmick. But it's just, right now, it's all hype. no, like, or 99% hype, 1% application, right? I don't know. I may be being a little unfair there. Maybe it's 90-10, but like it just really applying that on a job site is extremely challenging.
And we're at early days. Yeah.
But what they're waiting for, and this is the thing that's like they and others are going to drive the adoption of these chips, not for use in our space, but you're talking about retail giants like Amazon, people that are doing all this packaging and servicing in these facilities and centers that are moving from people walking around them doing it to robots walking around. Well, what do robots need to be able to do that? Well, they need high accuracy, medium range LiDAR, and they need it in a small form factor and low power. And so it's robotics companies like Boston Dynamics and the stuff that they're doing that are going to drive chip manufacturers to start producing, this kind of LiDAR. And, that or iPhones, as there get to be more use cases on the iPhone side for the little LiDAR chip that they've got in there, right? So same kind of thing. That's going to drive high accuracy, low cost, low energy footprint, small form factor LiDAR. Those sensors will in turn filter back into this industry. And then you'll be able to take something like Spot with a bunch of those sensors on it. And then you'll have a super compelling thing, right? But it won't be walking around the job site to document it. It will be used on the job site to install work.
Yeah, and you brought up the iPhone. It is interesting to me to think about not just continuously as-built models, but just real-time streaming of the built environment in so many ways, from so many, crowdsourced type of events, for instance. You can imagine a stadium filled full of people at a sporting event, capturing the event in 3D real time and beaming that across the planet for others to experience at the same time in a very real way to them that there would be no other way to accomplish.
Pop on their VR headset, pick their seat, and
it's
boom.
Incredible.
So no, it's I think you're absolutely right. And that's still probably 20 or 30 years out, but it's, that is the kind of future that this technology can eventually enable. And so like, please people do keep buying Spots, like keep Brian in a job because he's awesome and they're doing really cool stuff. Definitely keep strapping terrestrial scanners to it, even though I think it's silly as all get out. But like, we got to keep doing that because, that's how you finance that next revolution. Absolutely. Right? Is by taking these things that are mostly hype and look cool, but aren't really going to be productive, but putting money into those companies and helping them move forward. Right. And so, even if this stuff, and there's other companies out there doing cool stuff right now that it's like, they may not be at that point where it's really something you can put in use practically on the job today. But like, I know construction companies and architecture companies don't have a lot of R&D money, but you've got to participate in and fund the future of those technologies. Otherwise, they'll just die and they'll never get into our industry. Yeah. And so like it is actually dependent upon funding those things to make them come to fruition. So, I can point out 20 other things that I'd say right now are 90% hype and 10% application. Doesn't mean you shouldn't go invest in them and experiment with them and learn them. Inkscape was that way for a while. And I was an early adopter of Inkscape, and it was a pain in the butt to use at the time. But like now, like you said earlier with rendering, now we're at that phase where it's like renderings are free, which is awesome. Yeah. And I can design in VR live, which is amazing. So it's like, it wasn't that way when we first started paying the money though. But you gotta get in early and help these companies, achieve what they want to achieve because we don't have unlimited magical funding coming from somewhere. We have to invest in the process of designing our future and that of our profession, of our industry, and that's exactly what this is. It is an investment in the future of our industry, and we have to care about the future of our industry. So we've got to put our money where our mouth is and help us get there. Exactly. Because we all like to hear about, VC is so big into the vertical construction space. But the reality is VC money comes with a lot of balls and chains and stuff. So if you're a small startup and you're trying to get into this space, VCs can give you a big chunk of change, but they expect a lot in return. And they expect to be able to guide you and tell you to do this, that, or the other. And they're usually they're the worst people to be doing that, right? They're like, well, we want you. I mean, I invested when when I had very little money. I invested in a small startup that I believed in, and they got some VC money. And the VC was like, well, you need to do this. And it basically put them in competition with Autodesk, Procore. It was literally the dumbest decision I could possibly imagine. And like me and the other small investors were like, this is a terrible idea. Don't do it. It's a terrible idea. Don't do it. But they had a, $1.2 million paycheck that required that they do it. And they needed money to pay the bills. So they did it. And sure enough, 2 years later, that company's out of business because you can't compete with Autodesk and Procore with only $1.2 million. So, it was a death sentence. And that often happens with VC money. And the way you avoid that is by investing early. And so, buy a license, even if it's not ready for production, and then give feedback. And like, here's what you need to do to make it better. And that's how you fund that future. I think we get the perception in the industry, and I felt this way too when I was not on the dark side, that we have no control over the technology, and our technology is always behind when it comes into our industry. It took us, 15 years longer to get real-time rendering than it took the automotive industry. I could spout out 100 examples. But that's because Ford was willing to shell out, $30 million to a company over 10 years to develop real-time rendering.
Absolutely.
And they couldn't sell it for 1/100th of that cost in the AEC space. Right. And so it's like, we've got to be willing to invest some money in these things so that we can make them happen.
Absolutely.
So,
well, there's a challenge
by
for everybody. That's a fantastic call to action for the audience. And it's probably actually not for this audience. It's probably for the people who maybe hopefully listen to the people in this audience, but it's great. Yeah.
Yeah. Yeah. But anybody that's frustrated with the pace of technological adoption in this industry, it's like, we can complain about it all day long, but I was always taught, look inward first. What can I do to make this situation better? And if I'm not doing something to make it better, I have no right to complain. And so as an AEC firm, if you're not investing in small companies to help them solve technological problems, you're part of the problem. And so put that money in.
Well, that is a perfect call to action at the end of this episode. Thank you so much. This has been a really fun conversation. I would love for you to have the opportunity to share places online that people can follow what you're doing and what your company's doing to push reality capture forward.
Yeah. So company, you can track us down at ClearEdge3d.com. You can find us on Twitter. You can find us on, LinkedIn, Instagram, blah, 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 all the usuals. Socials. I would also say if you're new to any of this stuff, go check out ScandiBIM University. So this is a community site. We've got a LinkedIn group for it. We've got about 12 hours of webinar content that's online. It's ScandiBIMUniversity.com. Super hard to remember. But go, it takes longer to type it in than it does to remember it. But go check it out. It's everything kind of soup to nuts, the laser scanning process at a high level, at a kind of medium level. This next year, we're going to be coming out with a lot of more detailed content, specific training. So more to come on that. Check that out. You should also totally check out Reality Capture Network. There's a laser scanning forum. There's so many great online resources if you want to get into laser scanning or ScandiBIM or things like that. So the community's there. You just got to look for it a little bit. But it's, we're all trying to grow it because right now it's such a small niche. Like we don't generally see other companies in our space as competition because the reality is all of us can grow a lot more by growing the market than we can by taking a little market share from somebody else. So
it's kind of like architecture. There's plenty of work for everybody and not enough people to do
the work's out there.
Not enough people to do it.
Yes.
Well, Kelly, this has been awesome conversation. We should definitely continue it. I feel like there's so many more things that we could talk about. So I appreciate your time. Thanks for hanging out with us today. This show is part of the Gable Media Podcast Network. You can see all the shows at gablemedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for eTroxel. Talk to you soon.